Hello. Okay. Hello everyone. It's now 11:05. So according to the UNSW policy, we start at 5 minutes after the lecture official starting time, so which is now. So we need to start. So I understand that some of you have another lecture or another class before this one. So if you are a little bit late, feel free just to come in. So no worries at all. But we'll need to start the lecture. Okay, hello, welcome everyone to the second lecture and also the first face-to-face lecture. I'm very excited about this one. And also, we created this QR code for you to ask questions if you are online. So if you're just in person here in the physics theater, you can just ask questions by raising your hand. But if you are online, because the chat was quite active from our experience the last week on Tuesday, there was a lot of chats in the YouTube chat. So to make sure that we didn't miss any of your questions, if you have any question, just scan the QR code and ask on the forum, and we'll make sure that we get to all of your questions. So this is for online, but if you are just in person, you can just raise your hand. And while you are chatting in the YouTube channel, please be mindful that we are an inclusive community. Cool, great. So let's go back to the lecture today. Wow. So today's lecture will all about Git. So I love this lecture so much. This is one of my favorite lectures in COMP1531. So before we talk about what is Git, so let's consider two problems that if we don't have Git. Okay. So for example, you are working on a software project for not only a couple of weeks, but also a couple of months, even multiple years. Okay, so how can you control the versions of your work? Okay, so sometimes you may, well, I made a mistake here. How can I go back to yesterday's version? How can I do that? All right. So this is the first problem. The second one is for all our softwares, like it's developed, maintained by not only by one person, right? So we work as a team, work on big software project. So how can we seamlessly collaborate on a big software project? So how can we do that? Okay, so now imagine that there's nothing called Git. What would you do? Like how can you take control of the versions, like go back to yesterday's version? Or how can you collaborate with a group of people on one single project? How can you manage the code, the project? Any thoughts, ideas? Yeah. Sorry? Use Git. Yeah, Git is the solution. But what if we don't have Git? Google Docs. Oh, I love it. Any other? Manually do version control. Okay, so this is the version of yesterday, and this is the version of today. Is that right? Yeah, that sounds good as well. Any other ideas, thoughts? What about collaboration? You want to collaborate with people on one single project. Maybe a Google Doc? Yep. What's up? Okay, yeah, okay. So I add a feature here at this line, like line 100. I add another feature there, like line 120. Yeah.
Sorry, you charge lecture says the path is a bit leaky.
Sorry?
The online lecture says the path is a bit spiky.
Is it because of my hair?
We'll try.
I will try. Yeah. Tell us if it's better. Okay, so Git is called a version control mechanism or system. It manages everything that we just discussed. And it solves the problem of working collaboratively with a group of software. It also takes control of your versions. Like if I want to go back to the version of 10 o'clock, 9 a.m. in the morning, so it helps us with that. So it works very similarly like programs like Dropbox or OneDrive that can maintain a history of files and also allow like working together with a group of people. So can we just use Dropbox or OneDrive for software project? Yeah.
So when it says it allows multiple pieces to work on the same file,
Yep.
at the same time, or they have to be working on it separately?
That's a very good question. So I just repeat this question for online. So when we say working on the same file together, does it mean like they can work on it at the same time or separately, right? We'll see it very soon. Okay, we'll see it how it works. Okay, so OneDrive and Dropbox, they are also version control tools, but they maybe not enough for a software project. So you can go back to the version of 10 a.m. or 1 p.m., but you cannot know which part is for which feature, right? So maybe I add a feature about like add a button here, another team member add a new page for another feature. So how can we manage this in like Dropbox or OneDrive? So we need a dedicated tool for us to manage the version and working collaboratively on software projects specifically. So this is where we introduce Git. So Git helps us with all of these. So Git is just, you can think of it as a program or tool that helps us. So it's just a program like VS Code or GCC or any similar tools. And it's built and designed specifically for programmers. So Git is a distributed version control software that you can have multiple users working collaboratively. For example, you may have user ABC working on their own laptop, on their computer, on the same project. And there are many different solutions for Git, but basically Git is just a command line tool. So for those of you who has used command line, it's just like CD or ls, and we use the node and for our JS file. So those are command line tools. So similarly with Git, so basically it's just a command line tool that you can use your terminal to use all the Git features. However, because it's so popular, right? So it's so useful, so many people using it. So so now we have like GUIs, like user interface, help us to navigate through like using Git. And those tools that we can see now, like including GitHub, Bitbucket, and also GitLab. But all of these are just Git tools, and their fundamentals, their basics are the same, just Git. They are just like the difference between Chrome or Safari or Firefox. They are developed by different companies, but they do the same thing. But in 1531, we use GitLab. Okay. So after you learn how to use GitLab, it's very quick to pick up others like GitHub or Bitbucket. So today we are starting to learn how actually we can use Git to control the version, how to collaborate with other software developers in your project. So we are going to do a lot of demos today. They are not just not much on the slides, but if you want to get a recap after this lecture, you can use this Git guide on the slide, and you can also follow the lecture recording to practice yourself. Okay, so who has got access to GitLab? Who has tried to access your GitLab? Yeah. Okay. For those who haven't tried yet, you can find your GitLab repository on our course website when you go to task. So this will link you to the UNSW official GitLab repository. Okay. So now I'm already on GitLab. So how can we start? Okay. So how can we create a new project on GitLab? The way we do that is when we go to the homepage of UNSW GitLab, on the right-hand side, there's a button called New Project, and all you need to do is to click on this button. So you can create a new project on your GitLab, and we create a blank project. Okay, so we are going to do this together. So we are going to develop this project together in this lecture. So can anyone give me a name for our project? So this is a project for us. So can anyone give me a name for our project name? Sorry?
Generic project name.
Generic project name. Okay. Yeah, cool. Any else? Yeah.
Train Truck Bandits.
Sorry?
Train Truck Bandits.
Yeah. Anything else? Cool. So, yep. Just test. Okay. Very cool ideas. Okay, so what about I just use this name, the project name that given by GitLab, my awesome project. Awesome project. I love your names. My awesome project. Yeah, just my awesome project. That's it. Okay, so then you will be asked to fill in to pick a group or a namespace. So you will have a group for you after this week, after you joined your 1531 group. But you can also practice under your own personal project repo. So for me, I just put in my ZID. Yeah, so you can see that after we put this project name, the project slug is automatically filled in here for us. So it's I'll set it as private, initialize repository with a README file, then create this project. Oh, sorry, I already had a project called the same, my awesome project. So what about what was that?
Generic project name?
Generic? Or
Generic.
generic. Sorry.
I see.
Generic project. Okay, cool. And my ZID again. Okay, create this project. Cool, you can see that this project, generic project, was successfully created, and the URL of this project was under the UNSW GitLab URL, and then my ZID, and then is this generic project. So this will be the URL of this GitLab project. Any questions so far? Okay, so now we have already successfully created a project on GitLab. Yay, the first steps. So now in this project, you can see there's only one file called README. So this is automatically created for you by GitLab. So basically just some introductions on how you can use GitLab and how you can play with your GitLab project. Okay, so now we created this generic project on GitLab. However, it's still just sitting on the browser. Right, so how can I work on this project locally? So you may be familiar using Visual Code Studio, right? So how can I work on this project on my Visual Code Studio? How can I do that? The way we do it is by clone this project locally. So it's just like copy the project from the remote folder to our local folder. So we call it clone from the remote repository to our local repository. Right, so it's just like copy something from the internet to our laptop. So the way we do it is by click on the code button here, and you will see clone with SSH. So when you follow the Getting Started guide on the 1531 website, you will learn how you can create this SSH key. Right? So after you create that SSH key, you can clone the project from GitLab to your local laptop. So you can copy this URL and then go to your terminal. Go to the folder where you want to copy this project to. So now I'm here in my lecture folder. So the command line, remember that we say Git is a command line tool. So we can do a lot of things just using command line. So the command line we use here is called git clone. And then you Control V just to pass the URL that you just copied on your GitLab project and return. It will be saying cloning into generic project, and it will ask you to put in the key that you set. So I put my key. Okay, so now it's done. So now when I list all the files here, you will see that there's a new folder called generic project is created and added here locally on my laptop. Yeah, so remembering there was only these two folders, and now there's one more folder created. And then let's cd to this folder, list all the files in this folder, just this README file, copied and passed onto my local laptop. So I can also show you on here. So let's go to this folder, lecture. Oh, it's too small, right? Sorry. So you can see that this folder is now on my laptop, generic project, and in there is the README file. Right, so now I have copied and passed this folder onto my laptop. So now I can play with it, add files, adding code, or changing things, or adding features. Right? All good so far? Any question? Okay, cool. So now you can open your most familiar VS Code, Visual Code Studio to play with this project. So you can open folder, find where you copy and paste. So for me, it's here. Okay, so now there's this README file. locally on my laptop. Now I can add files to it. For example, I can add, what about, we learned JavaScript in our last lecture. What about we just have a quick recap of JavaScript? Variables.js. So now I created a new file called variables.js under this generic project folder. Let's declare a variable called A. It is the string called COMP1531. Yep. Can anyone remind me how I can print?
Console log.
Console log. Perfect. Thank you. Console log and then just A, right? Yeah. So now I've added a new file called variables.js, and I also add 2 lines in this file. Yeah, so I think I've done my job about variables.js file. Oops, sorry. So when I go back to my generic project and I refresh this page, where's this variables.js file? It's not synced, right? What happened? So how can we make this local change sync to our remote GitLab repository? How can we do that? So let me show you this one. Okay, so before we do more demos, I'll explain to you what is happening here. So what we see here, this here on the GitLab, you are this is called a remote repo. So this is what remotely on GitLab. So GitLab, you can just think of it as a server, as a big machine. And this is our working directory. So everything that's sitting on my laptop, what I just changed, all these changes are on my working directory. So this is called working directory. However, between this working directory and this remote repo, there are 2 more stages. There's also the staging area, there's the local repo, and then it's the remote repo. So there are 2 steps in between. So how can we push our change on this working directory to this remote repo? So how can we do that? The way we do it is by using, so I will explain more to you what is happening here, but I'll just show you how it works. Okay, I'll come back and explain. So what we do is we first use another command line of git is git add. So let's add this variables.js. So what this command line did was pushed the change on this working directory to this staging area. Okay, what is staging area? Okay, I will explain. Okay, but just show you first. And then it's now on the staging area, still not on the remote repo. So what we do is we git commit -m, give it a message saying like what is changed here. So what is changed is I add this variable.js file. Okay, so now this change is committed, meaning that it's now here on this local repo. However, still not on the remote repo. What we do is we use git push. So now we can push to the remote repo. Still confused? That's okay. I will explain. I'll just show you the whole process, and then I will break down and explain to you the details. And now let's refresh this remote repo. You can see that this variable.js file is here on GitLab. And when you click on it, the 2 lines are also here. Okay, so you may have a lot of questions here now. What is the staging area? What is local repo? Why do we need to push a few steps to sync on GitLab? So why? Why are these? Okay, so I'll explain to you one by one, step by step. The reason is, let me show you this again. So all we changed here on my laptop on this Visual Code Studio is sitting on this working directory. This is because you are working on a feature. For example, you are adding a button, right? So you may add a lot of things, changing a lot of things, but you do not want to mess. So for example, you have a website that is working, right? So this working is used by your users, but now you are changing something. You are adding a new button. However, you do not want to break the experience of the users because they are still users using your website while you are changing something, right? So you want to make sure that you do not break it. So and also you want to make sure that your team members know what you are doing because you are collaborating with your team members, other developers in your team, right? So for example, I add this new variable file. How should I explain? So let's put it here. Let's add more changes. Okay, so another way of declaring a JS variable other than const is let, right? So let's let another variable called 24 terms array, right? So I made a change here in this file. And I also make another change. So what about I add another file, which is about arrays, arrays.js. And I const an array with, A and B. Right. So these are two different features. One is about variable, one is about arrays. So maybe one is about thinking about a feature in your website. One is about a button. One is about adding another page. Right. So you want to communicate these changes in the history separately, right? So you do one thing, but you also do another thing, but you do not want to push all these changes together to the history because they are about different things. You want to make the history very clear. Well, this change is about a button. Well, that change is about a new page. You want to make it clear in the history. So what we just worked on, the working directory, is we changed the variables.js. However, we also made another change on the working directory, which is add new array.js. Right, so these are two separate changes. Can you see clearly from the back? Okay, cool. So these are two different changes. Right, so now I think that this arrays.js file is not done yet, but I'm done with the change with the variable. So this feature is done. So I only want to commit this change about the variables. So what I can do is I only add this change about the variables to the staging area, but leaving the arrays.js still at the working directory because it's not done yet. I haven't finished this feature yet. So I just leave it at the working directory, but only put the changed variables to the staging area. So what we can do is we only git add the variables.js. Sorry, a typo here. Variables.js. Variable, no s. Sorry. So now after I use git add variables, the change about this variables.js is on this staging area, but the new arrays.js still at the working directory. Okay, I'll show you more. Yeah. Okay. So now I want to commit this change about the variables. So I git commit -m change variables with a let. Okay, so this is my message about the change on this variables.js. So I commit this change about the variables. Now it's at the local repo. It's ready to be pushed to the remote repo. However, this new arrays change is still at the working directory. So you separate the change. You group the change based on the features, the problem, the bugs that you are solving or adding or changing. Yeah. Do we have any question here? Oh, a lot of questions. Okay, so another use for git command is called git status. So you can use that to check the status of your working tree. So this is called a git tree. So you can see this array is untracked because we never added to the history yet. So it's still just only add a working directory on your own local laptop. Right. So now let's make some more changes. Const names. Okay, so let's have a little bit break. Who wants to introduce yourself to the cohort? It's great to have an in-person lecture. Who is brave enough to introduce yourself? Yep. Sorry? Daniel? Daniel. Welcome, Daniel. Okay, who else? Who wants to introduce yourself to the cohort? Yep.
My name is Kay, K-A-Y.
K-A-Y. Welcome, Kay. Anyone else? Yep. C-U-O-N-G. Welcome, Kwon. Okay, cool. So now we made some more changes about arrays. And I'm going to have another file called arrays.js. So now I have two files. Both of them are about arrays. Alright, so maybe you are adding a button feature, but you may have more than one file about one single feature. So this is common, right? So it doesn't necessarily like you have one single file containing everything about one feature. So sometimes you may have two files. So let's have so now let's define another array, which is called what about programs? Okay, so may I know which program or degree are you doing? Computer science? Who is doing computer science? Yay, wow. Computer science. Who is doing software engineering? Wow. Software engineering. Who is doing computer engineering? Welcome. Oh, two. You are not alone. Computer engineering. What else? What are the other degrees they are doing? Science? Math? Okay, and others. So let's just put this here for now. So now I have made two changes. One change is in this array.js file about arrays. And I also made another change in this arrays-loop.js. So two files. I made changes in two files. But both of them is about one single feature. It's about arrays. Right? So normally what we do is we pack the changes together and push them together to the remote repo. So we pack them together. So let's take a snapshot of all these changes now that I made about these arrays. So what we do is we git add arrays and arrays.js and arrays-loop.js. So now let's git status and check. You can see that this arrays.js and arrays-loop.js, they are both added from the working directory to the staging area. So we add new arrays.js. We also add arrays-loop.js. So both of these are now at the staging area, and they are all about the same feature about arrays. So what about we take a snapshot of the changes about arrays now at the staging area and commit them together using one commit message. So the message in the history is the change about the arrays. Does that make sense? Yeah, so what we can do now is we commit them together, git commit dash m, and then add arrays files. Yeah, question?
So every time you make an edit, you got to go through all the steps, or can you just git push? Like, do you have to go through those steps every single time?
Good question. So I'll repeat this for our students online. So the question is, whenever we made a change on the working directory, can we just push everything together and push everything to the GitLab remote repo instead of going through the process of git add, git commit, and git push? Can we have a guess from the audience? What is the answer? Yeah.
Well, if you want to make changes immediately visible to the remote repository, then you do need to add
Yeah, so it is possible, but we do not recommend doing that. The reason is that we do not want to mess up the history, so the version history. Remembering that Git is a version control system, that you want to make your history very clear, that when you want to go back about a change, that you know where you should go back to. Right, so I added a button, I don't like it, I want to go back to the version before I add this button. Right, so you want to make things very clear. Okay, and also maybe because if you just push everything regardless which feature it is about, you may push together the feature about adding the new page, adding the button, but when I want to go back about the button, it's nowhere because you also go back to the changes that you made about the new page, right, because you mess up the history. Does that make sense? Yep. Cool. So you can think about what is on this staging area as taking a snapshot and commit the change together about one change, one feature. So you group things together, make the history very clear. So this is why we have this staging area. Yep. Questions from online? Yeah, we have a question online about what is this dash M. So this dash M is a flag. So it means that we want to add a message about this commit. So after that is this is the message about this commit. So what you can do is you can use git log to check all the history of your commits. So to check all of the commit history. So when you use git log, you can see that we start with, wow, this is very messy. So these are the histories. So for example, okay, so we start from the initial commit where we created this project, this generic project. And the first commit that we did was add this variables.js. So this is our first commit that we did. And we also had another commit, change the variables with a let. We also add the arrays file. So it's very clear what we have done. Yeah. Cool. Cool. Looking at the chat. Cool. Okay. So this is the process that you push your changes on your working directory to the remote repo on GitLab. So now let's have another look at our remote repo here on this generic project. Oopsie. Yeah. So you can see that here we still only have this variables.js on GitLab. The reason is that we haven't pushed the changes about the arrays to the remote repo yet. We only commit the change, but we haven't pushed it yet. So a very useful command is git status, where you can always check the status of your project. So you can see that the branches are had by 2 commits, that we made 2 commits our local repo, but we haven't pushed it to the remote repo yet. So we can do is git push them to the remote repo, and it's done now. Refresh this page. now you can see the arrays files are now on this remote repo on GitLab. You can also click on it to check. Yep, it's the same. Cool. Another thing that I found useful by using GitLab GUI is you can check all the commit histories here on GitLab as well. So you can see that this is our initial commit, and then 60 minutes ago we added variables.js, we changed the variable with select and then add arrays file. So this is the commit history. And then you can also click on them to see what is changed. So you can see that with this change, with this commit, so this is what we changed. We add 2 new lines, these 2 new lines, and let's check other commits. So under this commit, what we did is we add this and we delete this. Right, so you can check what you did, what you changed, and in each commit. So this is very useful using this GitLab GUI. Okay. Cool. You can also see the commit for each file. So you can see that the last commit for both arrays.js and arrays-loop.js is the same one because we packed them together, take a snapshot of them together, and made the same commit message. Right? Yep. Any question? Okay, so this is how you, as a single user, can use GitLab or Git version control system. But in many cases, you do this with your team members, or you may have multiple laptops. So for example, so now I work on my laptop in my office on this project. And I left my laptop in my office and go back home using my another computer at home. So how can I sync the files on different computers? So how can we do that? Okay. Yeah.
Maybe you can just use it to push changes made in the
Yeah.
office and then pull them back at home.
Yeah. Yes, that's right. So the way we do it is we push every change on my laptop to the Git remote repo before I finish my work in my office. And then when I go back home, I can use another command called git pull to pull everything from the remote repo to my another computer. So let me show you how we can do that. I will show you by using Tiger VNC. So Tiger VNC or VLab is just another computer, right? So it's another computer sitting in CSE somewhere. Oh, sorry. What is my password? Huh? Yep. Have you used VLab before? Yeah, that's nice. So it's just like another computer sitting somewhere in K17. So what we can do is to be able to pull everything from remote repo to your local laptop, you need to know the URL. You know which project you want to pull from the remote repo to your local laptop. So I need to open my browser first, which is a little bit slow. Let's imagine that we are working on 2 different laptops. Right. So I can't copy from here to here. So the way you do is you go, it's complicated. So when you use GitLab, you will notice that they will ask you to put this verification code, and all you need to do is using this authenticator from UNSW, and there will be a code and the GitLab. So that will be cool. So I'll go to my own personal projects, find this generative project on VLab, and then what we do, remember how we git cloned from GitLab to our computer. Remember that we click on this code button and there's clone with SSH. We copy this URL, open the terminal, and go to where we want to. So I'm going to document, and then I'm going to use git clone. Alright, git clone. So now there's a new project called Generic project on my VLab computer. Oops, C, D. And under there you can see there are arrays/loop, and readme and variables.js. So it's synced with the remote repo. So now I'm at home using this computer, the VLab. Okay, I'm going to make some changes. Oh, sorry, what is happening here? Visual Studio Code. Opening my Visual Studio Code on my VLab computer, and open the file of generic project. Sorry, I should open a project rather than open a file. Open a folder. Yeah, I should open the folder. Open it. And now you can see that arrays.js and others, all the files are here. So now I'm going to make some changes. Okay. Is it too small? I'll make it larger. Oh, is it too large? Okay, so let's play something with this variables.file. So what I'm going to do is I'm going to declare another variable as c, and c equals to 1 plus I'm going to ask you, what is this? Can anyone tell me what c will be? 1 plus 1, and c will be 2. Any other ideas?
Could be a bit.
1, 1? Yep. Do you agree that it should be 2? Hands up if you think it should be 2. Okay. Who thinks it should be 1, 1 or 11? Okay. Okay, let's see. Let's try. New terminal, and then I'm going to console log. Console.log c. Okay, Control S. Can anyone remind me how I can run this variable.js file? Yep. Node. Yep. And then variable.js. The answer is 1, 1. Why? Can anyone tell me why?
I'm
Yeah.
pretty sure the
Sorry.
last one is the dominant class, like the string, so it just turns the first integer into a string.
Yeah, that's true. What did you want to say? Yeah.
Okay, so the second one is string, and when it comes with plus sign, it will be like string concatenate.
Yeah.
So it will concatenate 1 and 1, so it will become 1, 1.
Yes, that's right. So both of you are correct. So I just explained to those online. Because the second one is a string, right? Remember that we talked about how we can put two strings together. Remember that we mentioned that, we can put two strings together by using plus. Right, so the double quotes and single quotes are the same, but I suggest that you use the one consistently. So because this one is a string, but you cannot calculate a string plus a number. So it automatically turns this one into a string as well. So JavaScript's type is dynamic. It's very interesting. Yep. So in this way, you actually put the first one into a string as well, and then put those two strings together. So 1, 1. So the 11 here you see is not a number, it's actually a string. Yeah, okay, so let's go back to Git. So now we made some changes on this variables file on my GitLab computer. And what I what should I do now if I want to push it into the remote repository?
First add
git add this variable.js, and then
message.
git, any ideas from this side? Git commit, is that right? Yeah, let's git commit dash. Can anyone give me a commit message for this change? Update variable.js. Yep, and then the next one is git push. Right, so now we pushed this change about variables to the remote GitLab repository. Okay, so now I finished my work at home. The next day I go back to my office and I'm using the computer in my office. Before I make any changes to the project, the first thing that I need to do is to make sure that my local repository is synced with the remote repository. Right, so the command line that we use is called git pull. That we pull all of the changes that we made yesterday to sync with the folder in my local laptop or my local computer. So I use git pull. Okay, so you can see that there's some changes in this variables.file file and it's changed. And let's go to the VS Studio on my local computer. You can see that all these changes are synced here on computer automatically. It's like magic. So Git is very powerful. All good? Tired? Shall we have a short break? Let's come back at 12 p.m. and we'll show you more demos and more features of Git. A break. welcome back, welcome back. Cool, there are some very good questions during the break. The first one is, a very common question is, why set up an SH key and Git clone works perfectly well on my laptop, but I try to Git clone on VLab, it doesn't work. Why? The reason is because you haven't set up an SH key for your VLab. So your VLab is like another computer, dependent on your laptop, right, your computer. So you want to use Git clone on your VLab, you need to have an SH key set up for your VLab, for that computer as well. So that will help make your Git clone work on VLab. Another question is, what if, like I work on this variables file on my laptop in my office, I made some changes and I forgot to push. And then when I at home, I work on this variables file, I made some IDs, and then I push, and when I go back to office, I push, and there are some conflicts. So I made two different changes, or what should I do? I'm going to show you.
You have to close your eyes and pray the second one correct.
Yeah. Okay. So this is called merge conflict. So this is very common, especially when you are working with different people on the same project. So sometimes you'll see conflicts in your project. So how can we resolve that? Okay. Let's come back to. So this is my laptop rather than VLab. Okay. Let's go to this arrays.loop file, and I'm going to add, for example, let's try for in loop. Const I in programs, and then console.log I, just console.log I, make it. What is I? Do you know what I will be here when I use for in loop?
The strings and the index.
Sorry?
The strings and the array.
The index?
No, wait.
Any thoughts here from this side? What I, yeah. It'll be 0, 1, 2, 3, right? So it'll be the index of, or the keys of this program's array. Here's another one, we'll just do this one first. So let's just console log it and see. So it's a good opportunity to recap what we have learned in the last lecture. So node arrays dash loops loop.js. You can see that is 0 to 3. So when we use for in loop, the I will be the index of this array. Right? Okay, cool. So now I made some changes to this array dash loop, and I want to push it to the remote repo. So what we do first is git add arrays dash loops loop.js, and then git commit dash m, give it a message. Can anyone give me a message about this commit? Anyone from the back? Sorry? Printing index? Yeah, that's good. Printing index. Cool. So now I git push this change to remote repo. Okay, now I went back home, work on my VLab. I forgot to git pull. Okay, I forgot to git pull this change from the remote repo. And then I go directly to this arrays dash loop. And what I did was I add something for const j of the programs, and then I console.log j. So this is what I did at home. Can anyone tell me what j will be? I'm now using for off loop, and j will be what about online? Yeah. the elements in this program array. So that will be computer science, software engineering, and others. Okay, let's run this file and try node and then arrays loop.js. Yes, you are right. You can see, just make it easier to read. So it's computer science, software engineering, computer engineering, and maths. Okay, and now I try to git add, git commit, and git push, and let's see what happens. Git add arrays. Remember that we also made some changes about this one on my computer, right? Other than WeLab. So we are expecting some conflicts. Loop.js, and then git commit. Can anyone give me a commit message for this change? Add for off loop, and then I git push. Uh-oh, something was wrong. Rejected. My push was rejected. Okay, what they are saying here is updates were rejected because the remote contains work that you don't have locally. This is usually caused by another repository pushing to the same reference. You may want to first integrate the remote change by using git pull before pushing again. So they give you very detailed hints. It actually tells you what you should do next. So let's just follow their hints and using git pull. Magic, what is happening there? Okay, you can see that something's happening here when I use git pull. So you can see that now in this array -loop.js file, we have both the for in loop and the for off loop. So when Git doesn't know how it can automatically merge the changes, it shows you everything, like the change you made on WeLab computer, the change that you made on your laptop. So it shows you everything, and you need to manually resolve the conflict. So what you need to do is just keep what you need and remove what you don't want. Okay, so for example, for this one, I want to keep both. I want to keep the for off loop. I also want to keep the for in loop. So I just delete the lines that I don't want and keep the ones. You need to manually resolve. Keep the ones that I want. Sorry, maybe. So just edit it and make sure that I got everything that I want. Yeah, question.
Does it tell you who's made those changes as well?
Sorry?
Does it tell you which remote repository is making those changes?
Oh, I already deleted that. Yes, they tell you where is it from the remote repo or whether it's from a local computer. Will show you more examples. So I already deleted that one. And now you have resolved the conflicts. You have now make sure that arrays-loop.js file contains everything that you want, doesn't contain everything you don't want. Now we can do is we do similar things: git add arrays-loops loop.js, and then again git commit -m. I'll put the message at resolve conflicts in arrays loop, and then git push, and the push is successful now. Okay, so when you go to the remote repo, you refresh the page on GitLab remote repo, you can also see this commit, resolve conflict in arrays loop. And when you open it, it contains both for off loop and for in loop. Yeah, so this is how we can resolve conflicts. Yeah, question? We'll practice how to resolve conflicts in the lab as well. So you will get the opportunity to practice. Question? All good? Okay, cool. That's amazing. So now let's show you something else. Let's go to the commits. You can see that some of the commits was made by HL. However, some of the commits was made by this J50307886. Why is that? HL is made on my local laptop, while J50307886 is made on VLab. Right, so if you work with your team members, the logic is the same here. Like as I show you how I work on my local laptop and how I work on VLab. Same logic when you work with different people on the project, on the same project. You can see who made the change, what change they made. You can see everything from the commit history. Cool. Sometimes Git can be very powerful that they can help you merge conflicts. Okay, let me show you some magic, what Git can do. So now I need to git pull first. Because I git push on VLab, before I make any change on my local computer, I need to make sure that I git pull first before I make any changes. Okay, git pull. Okay, so you can magically everything appears here on my local VS Code Studio as well. Cool. So let's make some changes in here. So let's add another file called objects.js. In this file, let's declare an object called fruits. Let me think. Name. What fruit do you like? Apple. Color. What color of apple do you? Oh, sorry. I forgot to put. Green or red?
Green.
Green is loaded. I will take green. Green. Okay. So now I declared a fruit object here on my laptop, and I git push it to remote repo, git add objects.js, git commit. Can anyone give me a commit message, please? Add fruit objects. Okay, and then git push. Okay, so now I made some changes here, and now again I forgot to git pull again. Silly me. But I also created a file on. Oops, sorry. How can I rename it? Object. I also created a file called object.js. Okay, and I also declared a fruit object here in this objects.file. However, I add one name and value pair in this object, which is number. So how many apples do I have? I have 3.
No.
I have a lot.
8,000.
Yeah. So I remember that I forgot to git pull, but I made some changes which looks very similar to the change that I made on my laptop. Okay, now I git add, objects.js and git commit -m, commit message and object with number, so just differentiate it. And then I git push. Let's see the message. Oh, still decline. Oh, yes. So when you create different files, let's do git pull first. So So I just answered the question from the previous one first before I talk more. So can you see which one was from the remote repo and which one was from the local repo? So you can see this is the current change. So it will tell you which is the change that you made here. Well, what is the change from the remote? Okay, so the current change is here that you made on your current computer. So resolve that first. Resolve it here. Okay. So git add, git commit. Sorry, I'll make it quick because I haven't shown branch yet. Resolve conflict in object. Okay, git push. Then I want to create some conflicts. So normally if I just change, what if I just change it to 31 here? Oh no, sorry. Git status. I just remember that I forgot to save this object.file before I git push and git add. So just make sure that I made it correct because I didn't save the file. Yeah, I modified it. I don't want to modify it. Save. Control S. Git status. Git add out. Git commit dash So what I want to show you here is sometimes Git is very powerful that they can resolve your conflicts for you. So for example, if you just add one character after stray, sometimes it will just resolve the conflicts for you. However, the worst case is Git cannot resolve your conflict, as what we just saying. You can just resolve conflicts manually. So that's the worst case. However, a lot of the time that Git can merge your conflicts for you. Yep. So this is what I want to show you. Cool. So now it should be up to date. I need to git pull here before I make any changes here. Yep, so you can see numbers here. So what if I add something about console.log these fruits? Yeah, I add something here. Sorry, I know it's a little bit. Git commit add console.log and then git push. Okay, so now let's go back to here. And then when we git pull, you'll see that it will merge the change for you. So see here in this object.js file, there's only the const fruit. So we just declare this fruit object, just no console log. However, when you git pull, it can merge this for you. Right, so this is merged for you directly. The worst case is that it cannot resolve the difference and you need to merge the conflict by yourself manually. Okay. Reading questions from online. Cool. Okay. Any questions about merging conflicts? Git push, git pull, working with different computers on the same project. Any questions about this? Yeah, question. Yeah, sorry, I didn't explain it. So the question was, what is git add dot? Like what we normally did is git add and then the file name. So I just, because we were short of time, so I just used git add dot. So git add dot add all the changes on your working directory in this folder. So we didn't specify which files change we want to commit, like add to the staging area. If I just use git add dot, so all the changes in all files will be added together to the staging area. Yeah, because I only made change in this file. So it's the same, we just use the file's name. However, if I make changes in multiple files and I use git add dot, the files that I have changed will be added together to the staging area. Yeah, it's just a shortcut. Cool, okay, great. So till now we have talked everything about Git solo. So when you work on Git with only yourself, so this is everything that you need to know. Working on single machine, working on multiple of your machines. So there's a cheat sheet that you can use. The command that we talk about include git clone, git status, git log, git add. Oh, we haven't talked about git diff yet. We'll talk about later. We also talk about git commit, push, and pull. Okay, so this is like basics of git commands summary. So everything you need to know about git command when you work locally. Now let's move on to the next part of Git. So team usage. So this is another powerful feature of using Git. So Git is primarily useful when you're working with others, not just yourself, right? So this is where we'll introduce branch or branching. Again, we'll do lab demo for this part of the lecture as well. Okay, so what is branch? What is branching? Why do we need that? Let me show you this. So let's imagine a scenario. Okay, you are a painter. Now you are not a developer, you are a painter. And you have a painting, a big painting hanging on the wall. And you want to make some changes to this painting with a group of your collaborators, right? What you don't want to do is, when you are unsure how to change or what to change, you don't want to just change on the painting directly, right? So what you may want to do is take a photo of that painting, print it out, try making changes on the printed version before actually make the changes on the actual painting. Right, so you are not breaking or make the painting broken because you are unsure like whether this adding or change will work or not. Right, so this is one scenario. Another scenario is you are writing a book with a couple of co-authors. Right, so you have a starting point of this book. So you already have a version 1 of this book. And you want to change chapter 1. Your co-author wants to make some changes to chapter 2. Another co-author wants to change part of the chapter 3. Right, so what you don't want to do is everyone working together on this single printed book. Sorry, I want to change here, and the other, turn to that page, I want to change chapter 2, and the other person says, oh, change to page, chapter 3, I want to change chapter 3, right? So this is what you don't want to do. Okay, so what you can do is make multiple copies of version 1, and you work on chapter 1, another person work on another printer of chapters 2, another person work on chapter 3. And then you can come back together and discuss, well, all these changes align well with each other. Now we can put this change to the actual book and then make a version 2 of this book. So this is the same when we work with software projects. So now you have a web app. So for example, our course website is working well, our students are using it. However, now I want to add a new feature. I want to group these pages differently. Right, so however, I don't want to make my change break the website. Like I don't want to, like, because I'm adding this new feature, working on the categories of the pages, and then in the meanwhile, our students cannot use this website. So this is not what we want to see. We want to make sure that while the students can still use this website, we play with the change at the back, and when we make sure that all the changes work well, we launch this new feature and every student can use this new feature. So this is what we want to do. How can we do that? Okay, so now the question is, how can we do that? So this is where we introduce branching. Okay, so this is the main branch, or sometimes you can see master branch. So this is the branch, or the version of the website of your software is being used by the users. And now I want to add a new feature. What I do is I make a copy of the current version of the website, or the current version of the book, or the current version of the painting. I make a copy of it, right? It has everything in the current version. However, I make a copy of it, and I add things, changing things on this copy, rather than the one that is showing on the painting, showing on the wall, or the website that is being used by the students, right? So I make changes on this copy. And after I make sure, well, it works, I think there's no bug, it works well, then I can merge it into the master or the main branch, so the working branch. And similarly, you may have some other person also working on it, so they also can make a copy of a version and make changes to it. After they make sure it works, they can merge it back to the main or master so that it can be used by the users. So this is branch. Okay, so this is very conceptual, very theoretical. So how can we do that? So how can we do this branching? Okay, so let's go back to this generic project. What we do is we can use, again, a command line called git branch. So you can now see that you are working on this main branch, and there's only this main branch in your project. There's no other branch. So now I want to add some new features about what? User data. Okay, so now let's create a new branch, like creating a copy of the current version that I can play with, make changes. So the way we do it called -b, and give it a name. Let's call it, can anyone give a name? Can anyone see online? Can anyone give a name of this new branch? About user data. What about just user data branch? User data branch. Uh-oh. Did I make something silly? Aha. Yes, I made something wrong. So the way that we create a new branch is called git checkout -b, and this branch name. So let's call user data branch. Okay, you can see now it tells you that you are now switched to a new branch called user data branch. And now when you git branch to ask them to list all the branch, you can see that there are two branches now for your project. Just the main branch, there's also the user data branch. And you are now on this user data branch. It means that you are on a copy of the current version. And the name of this copy is called user data branch. So this copy not only has everything, like all the code, all the files that you had on the main branch, it also had the commit history. So the commit history is also copied. All the files, all the data are copied in this user data branch. So it's a full copy of the current version. Yeah, so we can use, for example, git log. You can see that everything's here. The log history is also there, like resolve conflicts, add object with number, add full object. So everything's here. So you copy not only the data, but also the commit history. So now we can make some changes to this user data branch. So where should we add this? Shall we? Here. So let's play with this arrays.js file. User data. So let's const user data. Shall we? Do you want to play with arrays or objects? Objects or array? Object. Okay, so let's have an object. In this object, we can have, for example, Daniel first. Daniel. And with Daniel, there can be some program. Daniel, which program are you in? So where's Daniel? Disappeared. Okay. What about K? Is K here? What happened? Oh no. Okay. I don't want to play this one. I'm so sad. User data. Const. User. I'm so sad. User data. Okay, let's do something else. Who else wants to introduce yourself to the cohort and promise to not leave till the end of the lecture? We only have 30 minutes. You won't leave. Anyone want to introduce yourself to the cohort? Yep. Andrew, welcome, Andrew. Andrew. Okay, who else want to introduce yourself to the cohort? Yeah. Liam. Welcome, Liam. Okay, now, great. Thanks, Andrew, and thank you, Liam. Now we have created this user data on the user data branch. So this change is only sitting on the user data branch. It's not on the main branch. Okay, so let's check. Let's use git status to check. You can see that you are now on branch user data, and you modified this array.js. Okay, so now I'm finished adding this new feature about user data. I want to push this change to the remote repository. What should we do? So it's the same process, git add arrays.js, git commit -m, add Andrew and Liam to arrays in user data branch. Okay, so this is our commit message, and then something will go wrong. When you use git push as what we did before, you will see the error message saying that the current branch, user data branch, has no upstream branch. Why? What is that? Like, we used the git push for multiple times in this lecture and worked well. What happened?
Well, you've created a new branch, but the issue is Git doesn't know, I guess, like where the branch is meant to come from, so you can't push because it's very important.
Yeah. That's a very good explanation. I'll just repeat that. So remembering what git push does is push your changes on your computer to the remote GitLab repository, right? So this is what git push does. However, we created this branch on our computer, on our laptop. The GitLab remote repo is not aware of this. Right, so when you go back to the remote repo and you refresh the page, just only one branch called main. So this user data branch is not on the remote repo. So how can you push this change to that remote repo on this branch? Because this branch doesn't exist on the remote repo yet. Right, so what we need to do is we follow their hint by using git push set upstream origin. So copy that, pass this. So now not only you push the change to the user data branch, you also make sure that the remote repo also having this branch. So when you click on here, you can see that other than main, now you have a new branch called user data branch. Right? So let's go to this arrays.js on main branch. So we are now main branch on the remote repo. We only have Daniel K and Kwon here. So Andrew and and Liam are not here. Why is that? Because the change we made was on the other branch, was on the user data branch. So when you switch to this user data branch, you can see the new users, Andrew and Liam, are here. So you can see that this change only sits on the user data branch. It's not on the main branch. Okay, so now I think, this new feature is quite stable. I think I'm ready to launch this new feature to the website or the painting or the book. So what we can do is we create a merge request. So we merge the user data branch to the main branch, so that the main branch also have all the changes that we made on the user data branch. So it's like you finished chapter 1 of the book. You feel like the change, you're pretty happy, you're satisfied with that. So you want to merge this change about chapter 1 to the main book. So what you can do, just using this GUI here, create a merge request, click on that, and it will automatically give you a title based on the commit message that you used. You can also add more description of what you did about this feature, what is this feature. And then, this is important while you are working in a group. You need to have a second person to review this change before you merge it into the main branch. Okay, so it's like you work on the book with a group of collaborators. You are pretty happy with the change after chapter 1. However, you want to make sure that this change also aligns with the changes the other co-authors are making about chapter 2 and 3, right? So before you merge it to the main branch, you want to have your co-authors to review this change. So what we do here is we add a reviewer, because I'm the only one in this generic project, but you will see your team members, your group members when you see the drop-down list. So I'll just choose myself as reviewers. I do not delete the source branch when the merge request is accepted. I create this merge request and then ready to merge, and then I just merge. Okay, so merge completed. Now when I go back to the generic project, I'm now on this main branch. When I click on arrays, you can see that this new line is here. So Andrew and Liam are added to the user data on main branch. Does that make sense? Yeah. Yeah, all good. Online, just checking. Okay, cool. So, yeah, so this is it about branching. Yeah, so we have seen this, how we can check out to a new branch. So you not only have all the data, the files, and also you have the commit history copied as well. Cool. Yep. Okay. So other things that we want to talk about is remembering that when we are writing a book, we have co-authors also making changes to the book. So what we don't want to see is, for example, I finished my changing about chapter 1. Okay. Sorry, let's go back to the original state. So we start with the same version 0, so the initial version, and we all created a copy of the initial version of the book, and I work on the chapter 1, my co-author working on chapter 2, right? I finished the first. I finished working on my chapter 1. I merged it to the main. However, my co-author is working on chapter 2 based on the initial version before I merged my chapter 1 to the main book. my co-author wants to make sure that their change aligns with my change to chapter 1. So that they want to be updated about the change that I merged to the main version of the book. Right, so what they may want to do is they want to merge the main so they want to create a new copy of the main book after I merged my chapter 1 to the main book. So they are building on top of the most up-to-date version of the book, rather than working on the old version of the book. Is that clear? Because I changed the book by merging chapter 1 to the book. However, my co-author is still working on the initial version of the book. So they want to be updated of what changes that I made to chapter 1 so that they can work on the most updated version of the main book. Make sense? Yeah, so how can we do that? So on Git, what we can use is, for example, my co-author is working on another branch called programs branch. So this is my co-author. He's working on this branch. I should check out this branch earlier. So you can see that I'm now on this programs branch. I already merged the change. How can I demo it? Okay, check out user data branch, git branch. So you can see that what I'm doing now is I'm switching between the branch, right? So you can use git checkout followed by the branch name to switch between the branches. So now I made some more changes to my chapter 1 on user data branch. Who else? I need another student. Introduce yourself to the cohort. Yeah.
Shay.
Sorry, how to? S-H-A-Y. Shy. Welcome, Shy. So I add more changes to the user data on my user data branch. I git add arrays.js. What should I do next? Git commit -m a message, add Shay to user data branch. Okay, git push. You can see that the next time that you push to this user data branch, there's no error message again because the remote repo already know about this branch, right? Okay, so let's go back to our remote repo on this generic project. So why I'm doing this, so why I'm demonstrating, like adding a new change to this user data branch is because before I made this change on user data branch adding Shy, I already checked out the new branch called programs. So on the programs branch, it still has the older version of the main branch before I added Shy, right? So now I merge this new change to add this new change to main branch. Sorry, I'm probably ready to merge. Do not delete merge. Okay, cool. So now I merged my change on user data branch to the main branch. So in arrays that you can see that we have Shay here. Shy or Shay, sorry. Shay, okay. However, now when we git check out to the new branch called, what was the name? Program? Is that program? Branch? Is that git branch? What was the name? It all called programs branch. So git checkout programs branch. When we are on this branch, you can see Shay is not not here. Sorry, because this branch is not up to date with the newest change on the main. Is that clear? Because we check out, like we created this branch before we added shape. So it still has the older version of the main because we check out earlier. So, so now on this program branch, let's go, sorry. So now I'm on this programs branch. I want to merge the newest change on main to my current branch. So I want to merge the main to my programs branch to make sure that my change on the programs branch can work well with the changes in main branch. So what we can do is we can git pull origin and then main. So you can see that magically shape is here now on programs branch. And then you can feel free to make changes on this programs branch. So you know that you get the most updated version of main. So this is very common when you work as a group on the same project, but you are working on different features. So one is working on adding a new page, another one is working on adding a button, right? So I'm working on the button, I finished earlier. I pushed my button feature to the main branch. The students who work on the new page needs to know about this new button is added to main. So they need to git pull from origin main to make sure that their branch, their feature branch is most up to date with the main branch. All good? It might sound yeah, question.
What if you've got two branches other than main that you want to merge? Is it similar?
Sorry, can you repeat that question?
So say you've got branch 1,
Uh-huh.
branch 2,
Yep.
and you want to combine them with branch 3.
Yep.
How would you do that?
So you want to combine, you want to merge branch 3 into branch 1 or branch 2, is that?
Yeah, and then just have one branch instead of those two.
Main branch, like you can't have, so you need to have at least the main branch. So you can't only have feature branch 1 without main branch. So main branch is the branch that we normally deploy, so make it available for other people to use. So main branch is always there.
So say you've got the main, like the main branch.
Yeah, we got the main branch.
Two more.
Yep.
And you want to combine those two?
You want to combine those two.
Yeah.
Yeah, you can do something similar. You can do git pull. So you need to first make sure that the branch is pushed to remote before you can merge that.
So both need to be pushed first.
Yeah, they need to be pushed first before you can merge them. Because if you do not push, that change will only be sitting on your group member's computer. So you cannot merge something that is not on the remote repo to your own laptop, right? So they need to be pushed first. And then you can do something similar. You can do git pull origin and then that branch name to your current branch. So you can merge that branch into your current branch. So for example, now I'm sitting on the programs branch. And then if I pull origin main, I'm merging the main to my current branch. But I can also pull origin from another branch. So for example, branch 1. You can do that.
So like, in that case, I've been using the example before, someone's working on like a button, and someone's working on
A page.
and then someone else is working on a different page.
Yep.
But you only want page 1 and the button to combine into one branch. That's possible?
That's possible. Yep. Cool. Let me see if I have missed anything. Yeah, I think that's pretty much everything for today. So you got practice this, and you see a lot of conflicts while you are working with your group mates. So this is very common. Just learn how you can merge that. If no more questions, that's all for today. Yeah, thank you everyone. Thank you.
So say you've got a 4 in loop